So, hi, Calc 3 students. We were doing this problem in class, and now we're going to finish it. So, remember that we want to find the absolute minimum and the absolute maximum of this function. So, the first thing is to kind of just be able to look at our rectangular region. So, like we discussed in class, it kind of looks like this. So, you have negative 1 and 1 in the range of x. And then in y, we have 1 and negative 1. So we have this rectangular region. And what we want to find is the absolute extremes here. So remember that we were saying that we want to find all of the absolute extremes that are inside here, right? And then we also want to find all the potential absolute extremes on the boundary, including the corners. So this guy, we're going to call it L1. I'm going to call this guy L2, L3, and L4. So these are four different lines. So there's two different steps for this. So the first thing is you want to find all possible critical points within the region. So we're going to look inside the region. This is usually the easiest part. And then after that, we're going to look at the boundary. And this boundary will include the corners. So there's two steps for this. So the first step is going to be looking inside the boundary, and that actually, looking inside the region. And that's usually the easiest part because all we really have to do is look at the critical points for the function. So we know that the function f of x comma y is equal to x squared plus 4y squared minus 2x squared y plus 4. And to find the inside critical points, well, all we got to do is take the partial derivatives. So the partial derivative with respect to x in this case will be 2x minus 4xy. And then the partial derivative with respect to y would be, what would this be? 8y minus 2x squared. Okay. And then what we're going to do is we're going to set them equal to 0. Okay, so you can see that if I solve the f sub y first, I have 8y equals 2x squared. So then y would equal to 1/4 x squared. And what I can do, I can plug that into the other guy. So what we're going to have is 2x minus 4x, and then y is just this 1/4 x squared equal to 0. So we're going to be left with this 2x. The 4's cancel out, and you're left with an x cubed. Okay? And then remember that we're not going to divide by x. Instead, we're going to factor x. So 2 minus x squared equals 0. So we're going to have x is equal to 0, and x is equal to plus or minus square root of 2. Now, if you remember, square root of 2 is not in this region. Square root of 2 is greater than 1. So this guy, and also the same thing can be said about the plus or minus. So this guy, we're actually going to exclude it. So that guy is not, because it doesn't lie inside the boundary. We're looking inside of the region, and actually square root of 2 is not in there, so we can go ahead and ignore it. So the one value is just x equals 0. So now we got to find its partner. So we're going to have y is equal to 1/4 0 squared, and that's going to give me 0. So the point 0, 0 is my only critical point. Okay? And that one lies inside the region. It lies right here. Okay? So what I'm going to do is I'm going to make a little chart of all my critical points. It's going to be a lot. So it's going to be 0, 0. Okay, that's my first critical point. And then later on, we'll figure out which one is the extreme. Okay, if it's absolute, or actually, let me just write f of x comma y. Because later on, what we're going to do is plug all of these guys in. Okay, so that's just looking at at the inside. Okay, so the inside. So now what we're going to look at, we're going to look at the boundary. Okay, so we're going to look at this guy first. So here's line 1. Okay, so the second part is looking at the boundary, and this also includes the corners, and the corners, you'll see how we're going to do that. So we're looking at line 1. You can see that at line 1 we see that x equals 1, and that's very easy to see, right? Because this is just at x equals 1. So if we were to look at this line, it would just be x equals 1, but notice that the range of the y values is between -1 and 1. These are basically the corners. This is going to be the corner part. So you can see that what we want is, well, at x equals 1, what exactly is happening to this particular function? So we're going to look at x equaling 1, and let's see what happens to this function. So when I plug in 1 into the function, f of 1 comma y, we're going to end up getting 1 squared plus 4y squared minus 2 times 1 squared y plus 4. So all I'm just doing is just plugging in the 1. So I don't need to really write f of 1 comma y. We can just write g of y. So this is just a function of just one variable. So we have 1 plus 4y squared minus 2y plus 4. So g of y is equal to 5 plus 4y squared minus 2y. And you can rearrange them if you want. Doesn't really matter. And remember that we are only looking at the interval from -1 to 1. So this guy right here, this is just a single variable calculus problem. Okay, so we're just going to take the derivative and set it equal to 0. So this is going to be 8y minus 2. So you can see here that y is going to be equal to 1/4. Okay, and remember that y was equal to 1/4 when the x value was equal to 1. So the point actually is 1 and 1/4. So that's going to be one of my other critical points, 1 and 1/4. Okay, so you can see that 1 and 1/4 is probably going to be around here, 1 and 1/4. So that one lies in the boundary. Now, one of the things that we also have to take care of is the corner parts. Okay, so at these corners, at these absolute extremes. So you can either look at those things, or you can just say, well, at x equals 1, we also got these y values. So these y values would be -1 and 1. So that would just be when x was equal to 1, y will be -1. And when x equals 1, y is equal to 1. So these guys are just the corner parts. So let me just go ahead and just write that this one was inside the guy, the whole region. This one was on the boundary. And these other two were corner points. So these were just corners. Okay. Oops. Doesn't look like corner. Okay. So that's the first one. Now what we got to do is the most tedious part, is that we got to do it for every single one of them. So now what we're going to do is we're going to do L2. So L2 over here, I'm going to look at line 2, see if there's any points there. So that one occurs at x equals -1. So now let's go down here. So we're going to look at L2, and that occurs at x equals -1. And here the range is still the same from -1 to 1. Okay, so let's plug in -1 into the function. Okay, so what we're going to get is -1 squared plus 4y squared minus 2 times -1 squared y plus 4. Again, we're going to call this something else. We can call it g, I guess. Doesn't really matter. We can call it h. So this is just going to be a 1 plus 4y squared minus 2y plus 4. And notice that we kind of get almost the same thing. 5 plus 4y squared minus 2y. Okay, so this, you actually get the same as before. This is going to be the same. Same as L1. Now be very careful, does not always happen. This does not always happen. Okay, we just got really lucky in this case. So it doesn't always happen because it really just depends on the function. But in this case, it did. One of the reasons why it did is because you can see that when you plug in x equals 1 and you plug in x equals -1, the -1, the x values happen to be as squared functions, which make it the same. Okay, so you actually just got really lucky in this case. So we don't really get anything. Okay, so it's going to be exactly the same thing. When we set this equal to 0, we're still going to get y equals 1/4. The only thing that's different now is that your x value is -1. So -1 comma 1/4 is your new critical point. Okay, so this is a new one. -1 comma 1/4. And then again, we also have our corner points. So we have our corners, which is going to be this guy. So it's going to be -1 comma -1. And then when x equals -1, my y is going to be 1 as well. Okay, so I just got those from there. So these guys were my corners, or my endpoints. And then this guy was just because it was on the boundary. Okay. And now what we're going to do, now we're going to do L3. So we're going to go back all the way up. And then we're going to find out what exactly is going on here at L3. Okay, so let's go down. So at L3, what's happening now is that y equals 1, okay? Because if you look at it, if you look at the boundary again, this is at y equals 1. So it's going at the y-axis specifically at 1. So y equals 1. And the range of x values in this case is going to be between -1 and 1. Okay, so I'm going to go ahead and plug in 1 into the y value. Okay, so what I'm going to get is x squared plus 4 times 1 squared minus 2x squared times 1 plus 4. So I'm going to call this something else. Let me call it, I don't know. Let's call this a sub x. I don't know. So this is going to give me x squared plus 4 minus 2x squared plus 4. So a sub x is going to be equal to 8 minus x squared. So we're going to take the derivative of this. I remember that x here is between -1 and 1. Take the derivative of this guy. We're going to get -2x and set it equal to 0. And we're going to get x equals 0. Okay, so we get a point, a critical point at 0, 1. Now, one of the things to note is that our critical points, or should I say our endpoints here, remember that x equals -1 and 1, so -1 and 1, okay, they occur at y equals 1, first of all, but these numbers, we already have them. We already have, already there. Okay, because if you look at the other ones, those were included in the previous corner. So if one of the things that you can do is you can just put the corners all into the critical points list and then not worry about them later. Okay, but we do got a new critical point. Our new critical point was 0, 1. So we got a new one, 0, 1. So this came from the boundary. Okay, so when I look at 0, 1, 0, 1 is going to be 0, 1. So we got 1 right there. Oh, and I forgot the other one. The other one was over here. Okay, so we got a couple of them. And then finally, we are finally at the last one. Okay, so the last one will be L4. And L4 happens at y equals -1. So L4, then you got y equals -1. So that means in this case, your x values are going to be from -1 to 1. So again, we're going to do the same exact thing, x comma -1. So we're going to get x squared plus 4 times negative 1 squared minus 2x squared times negative 1 plus 4. So I'm going to call this b sub x squared plus 4 plus 2x squared, because there's a negative and a negative, plus 4. And what we're going to get is b sub x is equal to 3x squared plus 8. So notice here that we didn't get the same thing as the other side, right? So again, it doesn't happen. Okay, so now we're going to take the derivative. And what we're going to get is 6x, set it equal to 0, so we get x equals 0. So that happens when the y is equal to negative 1. So one of the critical points would be 0, negative 1. Okay, and again, we're not going to include the other guys because those guys are already there. Negative 1, and 1, negative 1 are the corners, so we're just going to go ahead and ignore them. So this guy's going to be 0, negative 1. Okay, so now comes the fun part. So now we're finally done. We're done with finding everything. Now what we got to figure out is we got to figure out what exactly all of these things are. Choose a different color. Okay, so let's go ahead and put in the function values. So the first thing that we're going to do is plug in 0, 0 into the function. And I already did this ahead of time, so this is going to be 4. Then into the original function, I'm going to plug in 1, 1/4. Okay, and I ended up getting 4.75. I'm going to plug in 1, negative 1 into the function, and I'm going to get 11. I'm going to plug in 1, 1 into the function, and I'm going to get 7. Then I'm going to plug in this negative 1, 1/4. And what I'm going to get is also 4.75. I'm going to plug in negative 1, negative 1. And when I get that, I'm going to get 11. Then I'm going to plug in negative 1, 1. And I'm going to get 7. And then I'm going to plug 0, 1 in there. Okay, so 0, 1 is going to give me 8. And then 0, negative 1 is going to give me also an 8. Okay. All right, so all we got to do now is just look at which one's going to be my maximum, which one's going to be my minimum. So we just got to look for the highest numbers. So if you can see, the highest number in this case, or yeah, I can say it's going to be at 1 and negative 1, okay, which is this guy, and also at negative 1, negative 1. So these guys are my absolute max. And to look at my absolute minimums, well, I just got to look at the smallest number. And if you look, the smallest number in this case out of all of them are going to be this 4. So this 4 is my absolute minimum. Okay. All right. So even though we got all these other critical points, they just happen to not be the absolute max and absolute min. Okay. So long and tedious problem for a very long problem. So just be aware that again, if you had something completely different, you like a triangular region or something completely different, you do have to check every single boundary, so every single side. So yeah, that's how you do this problem.